Assalamualaikum warahmatullahi wabarakatuh. Greetings everyone. My name is NURUDDIN SABRI. Me and my group are going to explain assignment electronic principle, question 2. My group is consists AZKHAIRIE bin AZWAN, Nick Muhammad AFHAM bin Muhammad AFFANDI, Muhammad AZMIE bin HASBULLAH.
Assalamualaikum warahmatullahi wabarakatuh. I am Muhammad AFHAM bin Muhammad AFFANDI and I will explain question 1, one Roman. Question is calculate base current IB, collector current IC, emitter current IE, and collector to emitter voltage VCE. So based on the circuit, the value for VCE is already given, which is 8 volt. So the value for VCE is 8 volt. To get IB, we use the formula VBB minus VBE over RB. VBB is 4 volt, VBE is 0.7, and RB is 4.7k ohm. And calculate, we get IB equal to 70.21 milliampere. To get IC, equation is VCE equal to VCC minus IC times RC. The value for VCE is 8 volt, VCC is 24 volt, and RC is 470 ohm. When we rearrange the equation, we'll get the final value for IC is 0.034 ampere. Next, to find IE, the value for IE is approximately similar to IC, which is also 0.034 ampere. And we write again all the answer. IB is 70.1 milliampere, IC 0.034 ampere, IE 0.034 ampere, and lastly VCE is 8 volt. So that's all for question 1, one Roman. Thank you.
I'm going to explain question 1 too. Classify whether the BJT in figure 1 is accurate or not. Use VCE set 0.3 volt and beta DC is 50. First, we're gonna find the IC saturation using formula VCC minus VCE set that given 0.3 volt and divide by RC. VCC is 24 volt and we have an answer 50.426 milliampere. And with after that we find IC using formula beta multiply IB. Beta is given 50 and IB that we find at question 1 is 70.21 milli, and the IC we get 3.505 ampere. So since IC value is greater than ICZ as specific value of DC gain, we can conclude that the transistor circuit is in saturation state. Therefore, IC value 3.505 ampere will never be reached where IC is saturated at 50.426 milliampere. Okay.
Assalamualaikum. I'll be explaining on question 2, which is refer to the circuit in figure 2. Determine the collector current IC, base current IB, emitter current IE, collector to emitter voltage, which is VCE, and collector to base voltage VCB. The given gain is 135. From the circuit, you could see that the circuit is emitter feedback by circuit. The VCC is 20 volt, RB is 270 kilo ohm, RC equal to 470 ohm, RE equal to 2.2 kilo ohm. Okay. First of all, we could use VCF, which is negative VCC plus VB plus VBE plus VE equal to 0. Then we could search for the unknown, which is IE. IE equal to VCC minus VDE over RA plus RB over gain. Get RB over gain because of the formula IC equal gain ID. Then just put in the value equal to 20 minus 0.7, which is VB, over 2.2 kilo ohm plus 270 kilo ohm over 125, which is gain. Then we get IE equal to 4.427 milliampere. And then IE is the same as IC, so we get IC equal to 4.427 milliampere. Then by to search IB, we use IC. which is IB equals to IC over gain, equal to 4.427 milliampere over divided by 125. And then we get IB is equal to 35.42 microampere. Then to search for VCE, we can use VCC, VRC and VRE, which is VCC minus VRC minus VRE equal to VCE. Then we get is VCC minus IC divided by RC plus RE. This is we factorize the IC from VRC and VRE. Then just key in the value and then we get VC of 8.18 volt. Then to the last search is VCB equal to VCE minus VDE, which is VCE is 8.18 and the VDE is 0.7. So we get the value of VCB is 7.48 volt. Okay, then we find all the question. Okay, thank you.
Assalamualaikum warahmatullahi wabarakatuh. Now we will continue to question 3. Figure 3 show a voltage divider bias circuit for bipolar junction transistor. Given DC gain is 200, the first question is determine whether the BJT is in steep condition or not. To know this BJT in steep condition or not, we must use this formula, which is DC gain times R emitter greater than 10 R base 2. So we insert the value of gain DC and resistor emitter, we can get 112k, and 10 times RB2 equal to 100k. So based on this value, we can know that DC gain times RE greater than 10 times RB2. So this BJT is in steep condition. For the second question is to calculate the collector current and collector to emitter voltage. So the first step is we must find VB. So we must use this formula, VB equal to R2 over R1 plus R2 times VCC. So we insert the value of R2 and VCC, can get 3.33 volt. After that, we continue to find VE. VE is equal to VB minus VBE. VBE is always 0.7 volt and VB is the value we just find. So 3.23 volt minus 0.7, we can get 2.63. And next, we find IE using the formula VE over RE, which is 2.63 volt divided by 560. So we can get 4.7 milliampere. We know that IE is equal to IC, which is 4.0 milliampere. Next, so this is answer for IC. So next we find VCE. VCE is VCC minus IC open bracket RC plus RE, 20 volt minus 4.7 milliampere open bracket 2k ohm plus 560 ohm. So 20 minus 12.3, we can get 7.97. This is value for VCE. Okay, that's all. Thank you.